Hello! Yes, and welcome to our Objective 4.4 notes. Objective 4.4 says I can solve quadratic equations by completing the square, and that, my friends, is what we're going to do today. So, completing the square is another process that we can use to solve quadratic equations. We've talked about solving by factoring, solving by the quadratic formula. We're going to review extracting square roots, which is one that we did way back in Unit 1, and now we're going to complete the square. So if you remember, in Unit 1 we discussed vertex form of a quadratic equations. We looked at this through a transformation perspective where K was the vertical shift, H was the horizontal shift, and H was the stretch or compression of our quadratic graph. So what I want to do to start, I want to review just how to solve quadratics in vertex form. So to solve a quadratic in vertex form, very straightforward. Looking at letter A, I'd start by subtracting 4. I want to isolate the quadratic, so it would be x minus 4 squared equals 81. And then I would take the square root of both sides. Now it's important to remember, whenever I take the square root of a number, I need to put the plus or minus. So the square root of 81 is plus or minus 9. To get x all by itself, I simply add 4 to both sides, and I would get that x equals 4 plus or minus 9. So what is 4 plus 9? 13. What is 4 minus 9? Negative 5. So x equals 13, or x equals negative 5. That would be my two solutions to this quadratic equation. Looking at B, same idea. Start by adding 4 to both sides. 16 plus 4 is 20, so I have x plus 3 squared equals 20. Once I have this value, this x plus 3 squared all by itself, I can take the square root of both sides, and that tells me that x plus 3 equals plus or minus the square root of 20. Think about 20 here, okay? So that's the square root of 4 times the square root of 5, so we would have plus or minus 2 root 5. And then to get x by itself, I just need to subtract 3. And I would say that x equals negative 3 plus or minus 2 root 5. And you probably think, gosh, it looks like almost a solution that would get from doing the quadratic formula. Yeah, right? This is just another way to solve quadratic equations. You'll get the same answer whether you use factoring, quadratic formula, or completing the square. So obviously the answer should look the same. So let's talk about the factors of perfect square functions. So if we have x squared minus 6x plus 9, I would factor this to be x minus 3 squared. X squared plus 16x plus 64. This is x plus 8 squared. X squared plus 2x plus 1. This is x plus 1 squared. X squared minus 12x plus 36. This is x minus 6 squared. So, look at the relation between the coefficients of these equations, like negative 6 and 9, and the value in the factor, negative 3. So, let's say I have x minus a squared. A is just a value, okay? So, a is b divided by 2. Do we see that? B divided by 2 for all of these. If I look at C, 2 divided by 1, 1. Negative 12 divided by 2, negative 6. And A squared is C. Negative 3 squared is 9. 8 squared is 64. 1 squared is 1. Negative 6 squared, 36. All right, so that's the relation that we need to notice when we're using completing the square. And it's very important because what we're going to do is we are going to make our quadratic equations factorable as perfect squares. Let me show you what I'm talking about. So, the idea behind completing the square is that any quadratic expression of the form x squared plus b over 2 can be written as x plus b over 2 squared. And that is the key. That is the key here. This is going to be our goal for writing our formulas. All right, so let's talk about the steps to completing the square. Make sure a equals 1. If not, divide. We have to have a leading coefficient of 1 here. So In this case, our leading coefficient is 2. We got to get rid of it. Divide both sides by 2. We get x squared plus 2x minus 6 equals 0. Then we're going to get ax squared plus bx by itself. Add 6 to both sides in our sample problem. We get x squared plus 2x. And I'm going to leave a blank. All right, and I'll show you why. We are going to add b divided by 2 squared to both sides. So what is 2 divided by 2? It's 1. What's 1 squared? It's 1. So I'm going to add 1 to both sides here. Now I'm going to factor the left side of the polynomial as a perfect squared. So x squared plus 2x plus 1 I can factor as x plus 1 squared. And in this case it equals 7. Now I'm going to take the square root of both sides, and be sure, don't forget the plus or minus here. So I take the square root of x plus 1 squared and the square root of 7. I get x plus 1 equals plus or minus the square root of 7. And then I solve and simplify. So all I need to do to solve for x in this case is just subtract 1 from both sides. So I have x equals negative 1 plus or minus the square root of 7. And there we go. That is how we can solve a quadratic equation by completing the square. So let's do some samples here. So this first one, k squared plus 4k minus 10 equals 2. All right, so first step, leading coefficient is 1, check. Next, got to get our variables on one side, so I'm going to add 10 to both sides. So I have k squared plus 4k plus blank equals 12 plus blank. Now, b over 2 is 2. 2 squared is 4, so I'm going to add 4 to both sides. Now I'm going to factor my left side here, so this would become k plus 2 squared equals 16. Take the square root of both sides, so I get k plus 2 equals, don't forget the plus or minus, square root of 4. And then to get, plus or minus 4, square root of 16 is 4. I don't know what I'm doing there. K equals, to get k all by itself, I subtract 2, so negative 2 plus or minus 4. So negative 2 plus 4 would be positive 2. Negative 2 minus 4 would be negative 6. So those are my two solutions here. K equals 2, k equals negative 6. Now look at letter B. Letter B is a unique situation. I need to get my variables on one side, so I'm actually going to start this one by subtracting 11x. So I'll have x squared minus 11x plus blank equals negative 28 plus blank. So this will be fun. 11 over 2 squared. Not every time is going to be a perfect number. We're going to have to be able to work with fractions. Well, remember, we can just square the numerator and denominator. So I get 121 over 4. 121 over 4. Negative 28 plus 121 over 4. Wow. So let's do some fun math here. So I can factor my left side as x minus 11 over 2 squared, right? It's b over 2 every time. That number in here, right? It's always b over 2. I'm sorry. Well, now, okay. That number in here is always going to be b over 2, right? Every time. That's the idea behind it. It can be a fraction. Don't worry about that. Now, that will equal negative 28. Boy, negative 28 times 4 would be what? Negative 112 over 4 plus 121 over 4. So that will become 9/4. So x minus 11 over 2 squared equals 9 over 4, which is actually hyper convenient when I think about square rooting things, because I would have x minus 11 halves equals plus or minus the square root of 9/4 is the square root of 9, 3 divided by the square root of 4, 2. So that's not awful at all. Then I need to add 11 halves to both sides, so x will equal 11 over 2 plus or minus 3 over 2. So x equals 11 over 2 plus 3 over 2, or x equals 11 over 2 minus 3 over 2. 11 plus 3 is 14 over 2, which would mean that x equals 7. 11 minus 3 is 8 over 2, which would mean that x equals 4. So there would be my two solutions here. X equals 7 and x equals 4. All right, for our final example, let's look at letter C here. 8v squared minus 2 equals negative 12v. Oh, how fun. So let's get this all organized here. Let's start, actually. I'm going to add 12v, and I'm going to add 2 to both sides. When I do that, I get 8v squared plus 12v equals 2. And now I'm going to divide by 8. Oh boy. So when I do that, I get v squared plus 3 halves v plus blank, I'll add something there, equals 1/4 plus blank. All right, so half of 3 halves would be 3/4. 3/4 squared would be 9/16. So 9 over 16 to both sides, 9 over 16. Wow. All right, so when I do this, factor, so I'd have v plus 3/4 squared, right? b over 2. It's always going to be that number we used to get. It's always going to be that number we used to find what we were adding, all right? v plus 3/4 squared equals 1/4 plus 9/16. So let's see, that'd be 4, so it would be 13/16, I believe, right? Because this would become 4 over 16 plus 9 over 16, which is indeed 13/16. All right, take the square root of both sides, and I get v plus 3 over 4 equals, I'd have plus or minus the square root of 13 over 4. Now this actually kind of works out well. We should always get the same denominator. If we get different denominators, we're either not fully simplified or we did something wrong. So I will subtract 3/4 from both sides here, negative 3/4. And when I do that, I get v equals negative 3 over 4 plus or minus the square root of 13 over 4. Which, if you wanted to write it as like a quadratic equation answer, that would be fine. You could totally leave your answer like this. That would be fine. You could also write v equals negative 3 plus or minus the square root of 13 all over 4. Both of those would be a-okay as far as final answers go. And that's how we use completing the square to solve quadratic equations. I know that was a lot. If we're feeling comfortable and we want to try it on our own, definitely hit up those practice problems. If you want to see some more examples, go ahead and check out the sample problems video, all right? This is Mr. Carter signing off. I'll see you next time.